Welcome back to another episode of Math Cafe, Enough Pie for Two. And sadly, still no pie.
Not unless you like 3.14.
Lame.
So today, we are going to be learning about central and inscribed angles and the relationship between them.
Perfect. So today you're going to need the worksheet, a protractor again, and a pencil.
No ruler this time.
All right, let's get started.
Have fun! So now we'll take out the handout with your circle and center labeled O.
Okay, like this.
Now in that circle, choose 2 points on the circumference and label them A and B.
Okay. So I'll make this point A, and I'll choose point B right here.
Join with A line, A to O.
Okay, so I'm going to join it from point A to the center, O,
And then B to O.
and from B, O.
Now
Okay.
measure the angle AOB and record the measurement on your worksheet.
So we're measuring the angle from A to O to B. Alright. And it looks like this is about 70 degrees.
Alright,
Okay.
this angle that you have created is called a central angle.
Okay, so angle AOB is called a central angle. So, okay, vocab alert. Okay, so we have a new word here, a central angle. So what is a central angle?
A central angle is where the 2 points on the circumference of the circle meet at their vertex in the center of the circle.
Okay, so it's an angle formed then by 2 points on the circumference and the vertex in the center. Well, that makes sense.
Makes sense.
Central angle.
Goes through the center.
Perfect.
Let's continue. Next, pick a 3rd point on the circumference of the circle and label this point C.
Okay, so I'll label C here. Okay.
Join A to C with a line and B to C with a line.
Okay, so I'm going from A to C and from B to C. Okay,
Now measure angle ACB.
so from A to C to B. Alright. Okay, let's get out our protractor again. Alright, pretty close there. A little bit off. Okay, this looks to be pretty close to 35 degrees.
Nice. Make sure you record this measurement on your handout as well.
Okay,
This angle you just measured is called an inscribed angle.
okay, so angle ACB is called an inscribed angle.
Vocab alert. So we have a new term here. Make sure you record this on your worksheet in the table for the definitions. Inscribed angle. So, Mrs. H, what is an inscribed angle?
Okay, so if we look at our diagram here then, it's an angle that is formed with 3 points on the circumference of the circle. So we have point A, point C, and point B. All 3 points are on the circumference. And that's an inscribed angle.
Thanks.
Perfect.
Okay, now let's talk about what feature central and inscribed angles share. Mrs. H?
Okay, so you're going to want to follow along with Mrs. F, doing the same thing on your example in your workbook as she's doing up on the board here. So start at point A, and we're going to look at the inscribed angle first. So from point A, I want you to trace your finger along a path to point C, back up to point B, and around to A. Right? Now we're going to look at the central angle. Again, starting at A to point O, the center, back to B, and around back to A. Alright, so along those pathways, what was the one common feature that both the central and the inscribed angle shared?
It was the sharing this arc between A and B on the circle.
Absolutely. That was the only time that your finger traced over the path twice. Okay, so what did we call this arc here?
This is actually called the minor arc
Okay, why is it called a minor arc?
because it encompasses less than half of the circumference of the circle.
Vocab alert, new term, make sure you get that definition in the chart in your workbook. Perfect. All right, what else should we look at here? So this is a minor arc. Is there such thing as a major arc?
Yeah, it actually is. If you look at on the other side of the A and trace back around to B again, this is what's known as the major arc. So it's the other part of the circle, all around this side, that gets all the way back to B.
And I guess they call it a major arc because it encompasses more than half of the circumference of the circle.
That's right.
Absolutely. Make sure you get that in your vocab chart as well. Perfect.
Let's look at another example. Take out your second circle with center marked as O.
Okay, like this.
What is the only example as to where the major and minor arc would be the same?
Okay, well, it kind of makes sense that the only time your major and minor arc would be equal would be when you have a chord that travels through the center, right? So when you have a diameter drawn in. So I'm going to label 2 points here.
Let's label them A and B.
Point A and point B.
Now I want you guys to draw a line that goes through A, O, B.
So from A to O goes to B.
Which makes sure it goes right through the center, which is also known as our diameter.
Right, so what we've drawn is a diameter.
Now pick a point on the outside of the circle, on the circumference, and label this point C.
Okay, I'm going to pick a point right here and call it point C.
Now you need to draw angle ACB.
So I'm going to go for point A. Whoa. Pause.
Pause the game.
Okay, we'll try this again. Okay, so after we've picked point C. Okay, so now you're going to...
Now you need to draw angle ACB.
Okay, so we're going to go from A to C, and from C to B.
Let's look at the arcs between points A and B.
Okay, sorry, say again.
Let's look at the arcs between points A and B. We're talking about there's no major and minor arc.
Yeah, but the arc, sorry. But why don't we say, let's just look at the arc that these two angles share in common. So what I've drawn is, okay, we'll pause. So
yeah, because you're saying between A and B, the arc between A and B, though.
Yeah.
No,
oh,
that's
sorry.
the diameter.
Sorry. This arc, yeah. I'm like, the wording just sounded weird. Okay, say what you're going to say again.
Let's look at the arc between points A and B.
Okay, then, what do you say after that?
Is there a major or minor arc? Because there's not.
But I think you want to point
What's
out...
the shape? Let's talk about what's the shape.
No, I think first of all you want to point out that I've drawn in a central angle and an inscribed angle, and this is the arc they share.
We never talked about that.
Yeah,
so
it's got to be more clear.
Okay.
Okay.
So do you want to go back to draw angle ACB, or are you good with that? You said pause. Okay, we're
Yeah.
good. Okay.
Okay, so what I'll do is, okay, I've drawn this in, and then I'm just going to clarify that this is my, okay, central and inscribed right now, since I'm here.
Go.
Okay, so what you've had me draw in then is clearly I have a central angle from AOB because it travels through the center, and then I've also drawn in an inscribed angle, ACB. 2 points on the circumference, and the third point, 3 points on the circumference. Try that again.
You have mind disease now.
Okay. All right. Okay, so clearly what you've had me draw in is a central and inscribed angle. So the central angle, 2 points on the circumference, the third in the center, right there, and the inscribed angle, points A, C, and B, right, 3 points on the circumference, so the angle formed here. So we've got a central angle and an inscribed angle, and they both share arc, AB. Okay, all right, Mrs. F, so what do you notice about the arc shared by this central and inscribed angle?
Well, I noticed that the arc between B and A, and then this arc between B and A are the same. So there's not really any major or minor arc at all.
So what's the special term given for this arc?
Well, to me, if you look and trace along this shape, it actually looks like a semicircle or a half circle.
Right, so this is actually called a semicircle.
Good. Makes sense?
Excellent.
So now we need to measure the angle formed by ACB and AOB.
Okay, so you're asking me to measure my central and inscribed angle. Let's look at the central angle first, AOB. And really, I don't need to use my protractor to measure this because it's a straight line. And we know that a straight line forms an angle of 180 degrees. All right, so this is 180 degrees. All right, so next you want me to measure my inscribed angle, ACB. Alright, so I'm going to need a protractor for that. And using my protractor, it looks like it's about 90 degrees. So angle ACB is 90 degrees. Okay. All right, Mrs. F. Now I think we should probably take a look at the relationship between the measure of the central and inscribed angles in the two examples we've done here. So let's go back one, and we'll take a look at the first example of central and inscribed angles we did, and let's take a look at this.
All right, so noticing patterns here in both of our circles is really important when we're talking about the relationship between central and inscribed angles. And notice that when we talked about our inscribed angle, ACB, it was 35 degrees.
Yeah.
And when we talk about our central angle, AOB, it was 70 degrees. If we do the math, the angle ACB, our inscribed angle, is half of the size of angle AOB, which is our central angle, that's 70 degrees.
Okay, so in this example, the inscribed angle is half the central. Okay, so let's take a look at our second example of central and inscribed angles.
Let's still see if that pattern and relationship holds true. In this one, our angle that's inscribed is angle ACB, and the measure of it is 90 degrees. In our central angle AOB, it is 180 degrees. Again, our central is twice that of our inscribed, or our inscribed is half of our central.
I'm detecting a pattern here. Excellent. Why don't we look at an example now? Oh no, first pause.
Yeah,
we
'cause
can
we're
come
just
to now.
talking about the
Let's put it all
summary.
together. Yeah. Okay, so we'll just say it, that central. We're deducing that central angles according to these examples. Central angles. Yeah. Okay.
And then we'll just say, you'll
put it
summarize,
together. Yeah.
put it all together.
Okay. So I'll summarize it, and then we'll go to say, okay, let's look at an example now. Fine.
You're going to have to say put it all together.
Sure.
Okay.
Okay, so let's put it all together. It looks like, therefore, a central angle, we'll start that again. I don't know where this better. A central
Do you want me
angle
to write that
is
down?
twice. No, I don't think you have to. Just a central angle. The measure of a central angle is twice of the inscribed. Okay. I'm going to actually say one more thing first. Okay. All right, so okay, let's put this all together then. We know that the relationship between a central and an inscribed angle is that they share the same arc on the circle. The other thing we know about that, about a central and inscribed angle, is that the measure of a central angle is twice that of an inscribed. Yes?
Perfect.
Perfect.
Yes.
All right, why don't we take that property or those properties and apply them to a practice question now?
Okay, let's look at some examples.
Excellent.
As I fully walk away from the camera.
All right, and it should be,
Next.
all right.
Okay. I'll talk about it
Yeah.
and then we'll move on. Okay.
Do you want me to use, so
I'll
I'll say
talk.
turn to question one and you look at and you explain it.
Okay.
You can go there. All right, so let's take a look at practice question one together. Mrs. F?
All right. So point O is the center of a circle. Determine the values of the x and the y of the degrees of both. So here's
Yeah,
x.
Let's
Here's,
word that again.
I know
Let's
that
say
was
determine
so
the
different.
values of
X degree.
angle x
Thank
and
you.
angle y.
It's just the degree that throws
One
me
more
off.
time.
I'm not a
And
math
then
teacher
and
at
then
all.
you push to it and then you can work through it.
Okay.
Okay?
Deal with these.
All right. Okay, so let's take a look now at practice question one together.
Okay, so point O is the center of the circle. And then we're also told that, no, let's start one more time because I want to say we're told that.
We're told point O is center.
Yeah, that's
it's
what I wanna
asking us
say.
to determine the values of it.
Yeah.
Fine. 1, 2, 3. Okay. All right, so let's take a look at practice question one together.
Okay, so it tells us that point O is the center of the circle, and then we want to find out the values of angle x and angle y here and here. So let's go to the next one and look at it a little closer.
Perfect. All right, so I guess we're going to have to apply some of the properties here that we just learned of central and inscribed angles.
Well, let's look at what we already know. We are told that angle ACB is 55 degrees.
And what kind of angle is that? We've got 3 points on the circumference of a circle. What would you call that?
That would be our inscribed angle.
Okay.
Then we also have angle AOB, which is the one we're looking to find, and that goes through the center of the circle. So what would that be called?
That's our central angle.
So looks like we have a central and an inscribed angle then.
Right, and they're both sharing the arc AB. All right, so therefore we can apply what we just learned about central and inscribed angles that share the same arc. we know that the central angle is what again?
I think, yeah, we did. We said twice.
Right, so twice the amount of the inscribed. So if the angle here formed by ACB is 55 degrees, that would make angle AOB, which is our central angle, twice that. So 55 degrees, all right, and if we times it by 2, 110 degrees. So AOB, or they've labeled it Y, is 110 degrees.
Perfect.
Okay,
Now that we know that,
let's just put this in here actually. Perfect.
and now that we know these values, it will actually help us find angle ADB. Because let's talk about what angle DB is. Angle ADB, again, has 3 points on the outside of the circle, or on the circumference, which means it's a,
Inscribed angle.
and then we have still angle AOB, which we already identified as a central angle. And so what do we know about an inscribed angle compared to a central angle now?
Well, and the fact that they share arc AB, right, is a must. They have to share the same arc. So since angle ADB, the inscribed angle, and angle AOB, the central, share this same arc, that property between central and inscribed angles holds true again. So if this is 110 degrees, the central, and angle X here, I'll do some blue, oops, is the inscribed, we know that it's half the amount of the central. So what's half of 110?
55.
Okay, so it would be 55 degrees.
And we can label that here.
Perfect.
Good job.
Well, all right, Mrs. F, let's take a look at practice question 2.
Awesome. So we are told again that point O is the center of the circle.
Okay?
Then we label each vertex. That's what we need to do now. So let's label each vertex and give them a name. So we'll label this one A, this one B, and then this one C.
Okay, perfect.
Now it says to determine each value of angle Y and angle Z.
Okay, so this is angle Z in here, and here in this triangle is angle Y. There, so we're asked to find those two angles. So let's look at this question a little more closely. All right, so we'll label our points again. Okay, so let's look at some of the things we know in this question. Right away, we have chord BA or AB that's passing through the center. All right, so right away there, it's a straight line, it's a diameter, and we also know that that's a central angle.
And that when we know, what do we know about a straight line is that it equals 180 degrees. And if we already know this angle, then the other angle must be taken away from 180 degrees to be given this angle here. So let's actually do that.
Okay, let's word that a little bit better.
Yep, that was terrible.
Yeah. So we're starting again. Okay. Okay, so we're taking a look at this a little bit better. Actually, let's just have it labeled right away. It's like magically appeared.
Yeah, because then you have to wait for me to do it and
Yeah.
then draw the things.
Oh, yeah.
Can you see the B and the A? Yeah, you can. It's red's really good.
It's because
Red really
close up
pops.
there. Okay. Okay, so ready. Okay. All right, so let's take a look at this one a little closer. All right. So what do we already know here? They're telling us that we have a chord, we can call it AEB or BA, that travels through the center of the circle, right? And what do we know about that then?
That means it has to be our diameter,
Right.
and it's also a straight line, which is really important.
Right, so what did we just talk about? Again, it's our central angle. It travels through the center. What do we know about the measure of a straight line?
That it's 180 degrees.
Perfect. And if they're telling us that this angle is 50, and altogether would be 180 degrees, we can solve for angle Z right now. How would we do that?
We would just take the full amount of the angle, which is 180 degrees, and subtract what we do know,
The 50.
and that will give us what's left.
Okay. And that's a pretty easy one. Right away, we know that angle Z would be 130 degrees. So let's put that in here. Okay, so now we just have to somehow figure out angle Y. And there's a couple ways we could go at this. I like using the isosceles triangle. I think that's an easy way to solve this. We know that in an isosceles triangle, the two angles formed by the equal sides are equal. Those angles are equal. So do we have any isosceles triangles here? We have a few.
Yeah, we do.
Absolutely. Okay, so we're solving this angle Y, and we know this is 130. What's the triangle formed here? With two equal sides, it would be?
I'm having trouble seeing this, to be honest with you.
Oh, this is an isosceles triangle.
Yeah,
Radius.
It's
radius.
this. It's because of the angle I'm at.
Oh yeah.
They're blurry. I can't see it.
It's blurry a little from this side.
Is it?
Pause.
Okay,
but not
sorry.
bad.
That's why you're like asking me all this, and I'm like, yeah, I think I see this. Oh, because then this angle would equal this angle, which
Yeah.
means that 180 minus 130
25,
divided by
yeah.
2. Okay.
Alright, let's start again. Actually, I didn't like the way I worded that anyway, so
Okay.
and then after. Get ready. Okay, so now that we've solved for angle Z, we need to solve for angle Y. So what kind of information do we have here?
Well, we do see that there is the radius on this side, and the radius on this side, and the radius on this side, so they're all equal.
Right, and the shape formed here is a triangle with two sides that are equal. What do we call that again?
Isosceles.
An isosceles triangle. And one of the important properties of an isosceles triangle is that the angles formed by the two equal sides, so this angle here and this angle here, would be the same. Alright, so if we know that this is 130, and that these two angles are the same, and one of them is the angle we're trying to solve for, y, it would make sense with knowing that all three angles in a triangle are 180 degrees. If we subtract 130 from that, and divide that by 2, we would figure out what angle y is.
Okay, well, let's do that.
Alright, so we're going to take 180 degrees and subtract 130 from it. We're left with?
We're left with 50 degrees,
Okay.
which is 50 degrees, which both of these angles share added together. So if we know that both of these angles must be equal, we would share the 50 degrees over two angles.
Okay, so if we divide 50 in half, we're left with 25 degrees. So we know that this angle is 25 degrees and this angle is 25 degrees. And we can just double check our math here that all three angles together should add up to 180. 25, 25 is 50, 130, that's 180 degrees.
Perfect.
Good job.
You too.
Alright, okay, so let's take a look now at practice question 3.
All right, so again, we're told about the point O being the center of the circle.
Okay?
It wants us to label each vertex, and we'll do that. A, B, and C again. And then we need to determine each value of angle X and Y, which is here and here.
Okay, so let's take a look at this question a little more close up. Okay, so we'll actually have to label this A, B, and C again. Alright, so how are we going to use the properties of central and inscribed angles, Mrs. F, to solve this?
Okay, so here it can become a little less clear about which ones are our central and inscribed angles. But you have to realize that you can turn this circle and look at it from any point of view.
That's a really important point, and it's really helpful in solving, isn't it?
Yes, I definitely think this is a helpful way for me to solve it. So let's look at this central angle AOB.
Perfect.
And then what inscribed angle would go with AOB?
Okay, so if we have AOB, and it's measuring 160 degrees, ACB, because it shares the same arc,
Along
would
the
be
red.
would be the inscribed angle. Perfect.
Awesome, so if we know that this is 116 degrees, we know that angle ACB is going to be half of that by the inscribed and central angle property.
Perfect. So that would be 58 degrees. So this entire angle would be 58 degrees.
Don't be afraid to show your work on your handout, even if we are jumping ahead.
Okay.
From here, let's look at the other view from Mrs. Huckluck's view. Oh, sorry. I'll just say it again.
Okay.
From there, let's look at the other view from Mrs. H's view.
Okay, so I'm going to look now at a different central and inscribed angle. So if we look at angle COB, all right, it has a measure of 128 degrees. The inscribed angle for this would be CAB, all right? They both share that arc. So this would be my central angle, this would be my inscribed angle. I know my inscribed would be half of my central, so the measure of this angle would be half of 128.
Which is 64.
Okay, so let's put that down. This entire angle is 64 degrees.
All right, now because there's a bunch of little lines in the middle here, it can get quite confusing. But let's look at the outside triangle here. This one, ABC.
So yeah, we have a triangle inside here. And what do we know about the three angles in a triangle?
They equal 180 again. So we have these two, which we can put together and then subtract from 180 degrees to get our third angle here.
Okay, so if we have 64 degrees, and we're adding it to 58 degrees, we have 122 degrees. And you want us to subtract that from 180 to figure out angle B? Yep. All right, and so that would be 58 degrees. So this angle is 58 degrees.
And remember, just because there's a line that looks like it's going down the center of this angle here, of 58 degrees, we can't automatically assume that we can just cut it in half and give us angle X. That is not a property we are ever told. We have to use the properties that we know. And in this case, we still know stuff about inscribed and central properties. So let's look here. We know that this is the inscribed angle here. We know we have another inscribed angle here. And then we have the last one in here. But the one we need to know is for the central angle AOC. So which is the inscribed angle that goes with that?
Okay, so if we have AOC, showing this arc, it would also be ABC, that would be the inscribed angle, right? And if the inscribed angle is 58 degrees, the central angle, which is angle Y, would be twice that. Right? So we know that angle Y, right, is going to be equal to twice, 2 times the 58 degrees. All right, so that would be equal to 116 degrees. Okay, so this angle is 116 degrees.
Now we know, because we've done this as well, sometimes these processes can be quite long, and you have to take a look at it and solve it like a puzzle when you're putting it together piece by piece. And sometimes we can find an easier way to do so. Pause.
Okay, no, we're not done yet.
Yeah, because what we're going to do
No,
is
we got
erase
to
this
solve
all
for angle
again.
X. Don't pause. Okay.
I was going to erase
Yeah,
this all
I
and
know.
do the easy way,
Yeah.
but yeah.
Okay. Okay. 1 second. Okay. All right. So now that we solve for angle Y, the last thing we have to do is solve for angle X here. And here's where again we can look at the fact that we know certain things about isosceles triangles. Right. So if we look right here, from the center out, right, and from the center out here, both of those are a radius, right? And now we have a triangle here with 2 edge lengths that we know are equal because they're both a radius. Therefore, this shape here is an isosceles triangle. And what do we know about isosceles triangles again?
Again, these 2 angles should be the same because they are across from the equal sides.
Perfect. So we know that if we subtract 116 from 180 degrees, whatever's left over, divide in half, and that will be equal to each of these angles.
Okay, let's do that.
So 180 degrees, take away 116, all right, and that would be equal to 64, right? Checking my math quickly. And if we take 64 and we divide it in half, therefore angle X would be
32 degrees.
32 degrees.
So each one of these is 32 degrees.
All right, so we took that and divided it in half. So therefore angle X is 32 degrees. Perfect.
Awesome.
All right, actually, let's take a look at this question one more time. There's many different ways you can go about solving this. We're going to actually show you an even easier way. Let's go back to this question and solve it a different way. Let's take a look at these 2 angles here, 116 degrees and 128 degrees. And we're asked to solve for angle Y. What do you notice about 1 full turn around here? That would form a
whole circle.
Perfect. And how many degrees are there in a circle?
360.
Perfect. So if we know this is 116, this is 128, how would we solve for angle Y?
Well, we could do the same as we do with the triangle one. We could add these 2 together and then subtract from the total, which is 360.
So together they add up to 244 degrees. If we subtract that from 360 degrees, we end up with 116 degrees again, which is the same answer we got solving it through central inscribed
So
properties.
it's a good sign that we're seeing that.
Perfect. And then now if we know we've solved this exactly like we did in the previous example, knowing that this is an isosceles triangle, these 2 angles would be equal. Subtracting 116 from 180 and dividing in half is going to give us the 32 again here.
So much quicker than the last time. But either way, because both strategies would be acceptable, you can do either one depending on which one you're more confident with.
Perfect.
I like that one. I like when you both cheers at the end.
vocabulary. Okay, so we have a new term here that you're going to want to put down into your vocab chart, an inscribed angle. So, Mrs. F, what is an inscribed angle? Sorry, this is getting ridiculous. We'll start again. Okay, we'll start again.
You're in your perfects.
I'm gonna switch it to excellent now.
They make me laugh every time.
I'm gonna be like, excellent. Okay. All right, vocabulary. So we have another new term here, an inscribed angle. So what is an inscribed angle?
An inscribed angle is where the 3 points on the circumference of the circle. Shoot.
Okay, we'll start that one again.
It's formed by 3 points. I'm like,
It is just 3 points. All right.